In a certain country, 10-digit telephone numbers with the following format we introduce. We have the area code with 3 digits and an example, the exchange code with 3 digits and an example, the number with 4 digits and an example. And then 10.1 says how many possible 10-digit telephone numbers could be formed. We are also told that the digits may be repeated. So we have 10 digits. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So for the first digit, we have 10 digits in math, right? From 0 to 9. For the first digit of the cell phone number, we are picking a number from 0 to 9. So we have 10 possible options. And then for the second digit of the telephone number, we're also picking from 0 to 9. So we also have 10. For the third digits, we're picking from 10 numbers and so on until the last digit, essentially, right? So we have 10 to the power 10. So it's 10 multiplied by 10 by 10 by 10 by 10 for 10 digits. So that's basically just 10 to the power of 10. So the number of possible 10-digit telephone numbers that can be formed is 10 to the power of 10 if the digits may be repeated. If the digits were not repeated, what were we going to have? We were going to have 10 factorial. But anyway, story for another day. Let's carry on. 10.2 says certain restrictions were placed on the groups of digits. And then for the area code, it must be 3 digits and the first digit cannot be 0 or 1. For the exchange code, it must be 3 digits and the first and second digits cannot be 0 or 1. Okay, and then for the number, we must have 4 digits and the first digit must be 0 or 1. How many valid 10-digit telephone numbers could be formed by applying the given restrictions? So we have the area code with 3 digits, right? And then we have the exchange code with 3 digits, and then we have the number with 4 digits. So for the area code, the first digit cannot be 0 or 1, right? So we are choosing from only 8 numbers because it cannot be 0 or 1. So we're going to have 8 possible numbers on the first position of the area code. And then on the second digit, we don't have any restriction, right? So it can be 10 possible numbers. And then on the third digit, we can also have 10 possible numbers there. And then for the exchange code, we are told that it must be 3 digits and the first and second digits cannot be 0 or 1. So for the first and second digits, we're choosing from only 8 possible numbers, right? Because it cannot be 0 or 1. So we're choosing from 2 to 9, 8 possible numbers. So we're going to have 8 possible numbers for the first digit, 8 possible numbers from the second digits. And then in the last digit, we don't have any restriction specified. So we're choosing from 10 possible numbers. And then the last 4 digits, right? I say that the first digit must be a 0 or 1. So for the first digit, we're choosing from 0 or 1. So we can have 2 possible numbers on the first digit. And everything else, we don't have a restriction. So we're going to be choosing from 10 numbers, from 10 numbers, from 10 numbers. So the number of possible 10-digit telephone numbers, if these restrictions are applied, will be 8 multiplied by 10 multiplied by 10 multiplied by 8 multiplied by 8 multiplied by 10 multiplied by 2 multiplied by 10 multiplied by 10 and then multiplied by 10 again, right? And then if you put this in your calculator, you're gonna get 1,024 times 10 to the power of 9 possible telephone numbers. And then 10.2.2 says determine the probability that any randomly chosen 10-digit telephone number will be a valid phone number. Any randomly chosen 10-digit telephone number will be a valid phone number. So we need 4 valid phone numbers divided by any possible 10 digits, right? Valid phone numbers divided by any possible 10 digits. So the number of possible 10 digits is 10 to the power of 10, which is what we calculated in 10.1. But then of those 10 to the power of 10, the ones that are valid, right, are only 1.024 times 10 to the power of 9, which is what we calculated in 10.21. So we're going to have 1.024 times 10 to the power of 9 divided by 10 to the power of 10. So basically 10 to the power of 10 is our sample space, right? And then 1.024 times 10 to the power of 9 is basically the likelihood of our event occurring. So that will be equals to 64 divided by 625, which is 0.1024. So that's the probability that if you just pick a 10-digit number in random, it will be a telephone number.